Okay, today I'm going over lesson 10, day 3, which is on page S85. We are going to prove similarity using all of the different methods that we have done. The first one I am going to do is using a dilation proof. Describe the sequence that would show triangle ABC is similar to triangle A prime, B prime, C prime. So the very first thing we're going to do is we're going to figure out, we're going from ABC, this is the first one, and I'm going to A prime, B prime, C prime. So I'm going from big to small. I always like to write that out, so therefore I can identify the scale factor. First thing I need to do is to find the scale factor. They did not tell this to me. So when I go to find the scale factor, luckily for me, I can count my horizontal segments, and I can also count my vertical segments. You're going to use formulas to show me. The horizontal segment is line segment BC, or B prime, C prime. So my formula is going to be the length of B prime, C prime is equal to the scale factor times the length of BC. And actually count. B prime, C prime is 3 units, and the length of BC is 6 units. When you divide both sides by 6, you get the scale factor to be 1/2. Now let's do the same thing using the vertical length. My vertical length here is the length of A prime, B prime. That is equal to the scale factor times the length of AB. And let us count. A prime, B prime is 1. AB is 2. When I divide both sides by 2, I get my scale factor to be 1/2, which agrees to the horizontal. Now, does that make sense? When I go from big to small, my scale factor is 1/2. Yes, it is less than 1. That works. Now what you're going to do is you're going to write out your coordinates. A, B, C. And you're going to list the points. So the coordinates for point A is -2, 4. B is -2, 2. And C is -8, 2. I am going to dilate using a scale factor of 1/2, which is what I just calculated. So I'm going to call them A double prime, B double prime, and C double prime. Take each coordinate and multiply it by 1/2. -2 times 1/2 is -1. 4 times 1/2 is 2. -2 times 1/2 is -1. 2 times 1/2 is 1. -8 times 1/2 is -4. And 2 times 1/2 is 1. Now what we are going to do is we are going to graph that dilated image. So I have -1, 2, -1, 1, and -4, 1. You are going to graph it, and you're going to label your vertices. Now remember, our goal is to map now that blue triangle onto triangle A prime, B prime, C prime. And if you notice the orientation of the vertices, they're flipped. So what I do want to do now is I probably want to think of my rigid motions that I want to use. Orientate your vertices correctly. So at this moment in time, we should be able to realize that I can reflect over that y-axis, and therefore my orientation of that triangle would then be correct. So we're going to reflect over the y-axis. And I counted my boxes and I was able to reflect. Now I'm not quite there yet. There's one more rigid motion that I need to do. So look at vertex A. And I would count. I have to move it 1 unit to the right and 1, 2, 3, 4 units down. So that's a translation. Translate 1 unit right and 4 units down. Then they coincide and my dilation proof is done. Now I need to do what I call precise language. So pause me now, write out your precise language, and then we will talk. my precise language for this dilation proof. Dilate triangle ABC from center O. Using a scale factor, R is equal to 1/2. Then reflect dilated image, again make sure you have all these words in here, across the y-axis. Finally translate the dilated image 1 unit to the right and 4 units down. Therefore triangle ABC is similar to triangle A prime, B prime, C prime. And that is your dilation proof. Let's go to the next page. I'm now on page 86. I want to now show that all of my sides are in proportion. You have to do this for every single side length. So I'm going to use my proportions and I'm going to use my words. Big over small equals big over small. We have to do every side length. So if I take a look at the big triangle, 6 corresponds to the 3. The 10 corresponds to the 5. And the 8 corresponds to the 4. So I'm setting up proportions. Let us simplify. 6 divided by 3 is 2. 10 divided by 5 is 2. And 8 divided by 4 is 2. My scale factor for all of them is the same. So yes, these triangles are similar since all sides are in proportion. Let's take a look at number 2. I'm going to do the same thing. Big over small equals big over small. So just make sure that you're using the corresponding sides. I'm starting with the 6. 6 corresponds to the 5. Does that equal the 6 over the 5 for the next 2? Those two correspond. Equals 8 over 7. Use your calculators. 6 divided by 5 is 1.2. 6 divided by 5 is 1.2, and 8 divided by 7 is 1.1428. Uh-oh, not in proportion. Not proportional, therefore these two triangles are not similar. You need your scale factor to be proportional, not similar. Let's take a look now at question number 1. Are the triangles shown below similar? Present an informal proof whether or not they are. This is number 1 on page 86. Well, remember, you can do a dilation proof if you're on the coordinate plane, which I'm not. Second way that I would try to find this is my angle-angle similarity theorem. I find that to be the easiest. I do have some angle measures here, so I'm going to look at angle A is congruent to angle A prime, so I'm going to write that down, which is equal to 25 degrees. That gives me an angle. And then when I look at angle C, I don't have angle C, and angle B, I have angle B prime. I'm missing some angle measures. So what I'm going to do in this top triangle is I'm going to put an X here, and I know that all of my angles inside a triangle have to equal 180 degrees. So X plus 25 plus 102 has to equal 180. Let us solve for X. And I get X to equal 53 degrees. Let's do the same thing now in the other triangle. I'm going to just call it Y. So I have 53 plus the 25 plus Y. That has to equal 180. And when I add these two angles up, I get 78 plus Y equals 180. Subtract 78 from both sides. And I get Y to equal 102. So now I have all of my angle measures. Thankfully now I can say that, woohoo, angle B is congruent to angle B prime, which is equal to 102 degrees. I don't have to state C because with the angle-angle similarity theorem, I just need two angles, which bingo I have. So I can say triangle ABC is similar to triangle A prime, B prime, C prime. I have angle, angle, similar to angle, angle. And just write out angle, angle, similarity theorem. And you're showing me all of the work to justify that those two angles are congruent. Let's go on to page 87. This is my situation. I have triangle ABC and triangle A prime, B prime, C prime. Is triangle ABC similar to triangle A prime, B prime, C prime, and explain? So the first thing I'm going to do is look. I'm not doing a dilation proof. I'm not on the coordinate plane. Let's look for angle, angle similarity. And I already know that I do have angle C is congruent to angle C prime. That gives me an angle, which is 85 degrees. And unfortunately, I don't have any other angle measures to look at. So let me look at number 3. Find all corresponding sides are in proportion. Well, I have all of my sides for triangle ABC. However, I'm missing this side over here for A prime, B prime. So I can't use that one. So now I'm going to think of that side angle side similarity. So we found one corresponding angle congruent. Now let's make sure my corresponding sides are in proportion. So let's do my proportion. Big over small equals big over small. Let's take a look at line segment AC. Line segment AC is 20.5. That corresponds to A prime C prime of 8.2. And let's now take a look at line segment BC, which is 18.75. And that corresponds to line segment B prime C prime, which is 7.5. Let us apply our cross products property and cross multiply. 20.5 times 7.5, is that equal to 8.2 times 18.75? Use your calculators. You're going to get 153.75 equals 153.75. So now we can say, yes, triangle ABC is similar to triangle A prime, B prime, C prime, because I have one pair of corresponding angles congruent, and corresponding sides are proportional. Side angle side is similar to side angle side. To answer the question now at the bottom, now I can find the length of A prime, B prime. So again, do big over small equals big over small. And I'm going to do the 20.5 over the 8.2. Those are the two side lengths that I know. Equals 26 over x, because I do not know A prime, B prime. Cross multiply. 20.5x is equal to 8.2 times 26. 20.5x is equal to 213.2. Divide both sides by 20.5. And you get x to equal 10.4 units. And just remember to box in your answer. Now we've just gone over all of the different ways to prove similarity. Please review these. And everything is on that orange sheet that I had given out to you.